Welcome to week 5. This is Data Analysis Scholarship course. Today we will be looking at correlation and regression analysis. Welcome to tonight's section, Data Analysis Scholarship using Microsoft Excel. And my name is Franklin. Welcome. Tonight we will be finishing where we stopped in the previous section. We will continue and finish where we stopped in the previous section, which is correlation and the regression analysis. We are going to be looking at how we can analyze data, do correlation analysis, regression analysis in Microsoft Excel. Once again, you are welcome. You are welcome to tonight's section. Let me know if you can hear me, if you can see my screen. We are live once again for tonight's section. We are gradually wrapping up cohort 1 of data analysis scholarship course. After today, on Saturday, we will move into the Power Pivot and then data visualization, how to create an interactive dashboard, and then we move to building a project from start to finish, a capstone project which we will use to wrap up this and data analysis scholarship. Welcome once again. I remain your facilitator, Franklin. Kindly welcome Shitu Olaitan. Good to have you. If you are in the scholarship group, which you should be, that is the only place I share the link for this section. The only place I share the link for tonight's section is in that data analysis scholarship group. So only those in the data analysis scholarship and our community members here on YouTube, our subscribers, that we get notification for this particular live training tonight. Alright, Shitu, let's get to the scholarship group and tag everyone. Let them know we are live for tonight's section. Let them know we are live for tonight's section, and we are starting earnestly. We are starting earnestly. We are not going to wait. I started 8 p.m. tonight because of we will need some time in order to wrap up this course. So we have been away for few days due to some technical glitch. So tonight we might definitely go beyond 2 hours thereabout. I will love to do that, but it depends on how tonight pans out. Okay. Welcome once again. Kindly confirm, drop in the chat, drop in the comment if you can hear me, if you can see my screen. Let's do that. We are live, guys. We are live once again. Let everyone know that we are live. As our tradition demands, go ahead and hit the like button on this live session and also share the link. Share this live to as many that needs to learn data analysis. In fact, correlation and regression analysis is one of the powerful tools we use in our analysis to make informed decisions, to make data-driven decisions, to predict outcomes. So go ahead, tag everyone in the scholarship group. I'm giving a minute or two for us to do that. Once you are done, just drop in the chat, done. Once you are done, drop in the chat, done, so that we commence earnestly. Once you are done, drop in the chat, done, so that we proceed immediately. Let's do that Let's do that. I'm waiting for us right in the comments. Yes, Shitu, you said I'm audible. Okay, go ahead. Tag everyone in the scholarship group. We are gradually coming to the end of this data analysis scholarship. Using Microsoft Excel, we are gradually coming to the end. And it is not the beginning that matters, it is beginning and ending. It's starting a thing and finishing it. And tonight, we are gradually winding up. We are gradually wrapping up data analysis in Excel. All right. If you have shared the link, if you have tagged them in the scholarship group, let me know. And if you have hit the like button on this live section, let me know. Let me know. Just drop in the chat, type in the chat, done. Type in the chat, done. All right. As we proceed, let's quickly run an overview from what we have in the last section. Let's quickly run an overview from what we have in the last section. Thank you, Shitu. Thank you for that. In the last section, we understood what correlation is. If you haven't, if you are not in the previous session, I will encourage you to go to the previous session and get to understand. I explained that effectively. It's just a recap, an overview. It's a statistical measure that describes the strength and direction of relationship. So for us to measure relationships in data analysis, in Excel, in any analytical tool, we use correlation. Correlation analysis is to measure relationship, and not just to know whether relationship exists, is to also let us know the strength and the direction of the relationship. That is one of the things we gathered in our previous section. Then we were able to look at key points about correlation, and we have the direction. We said about the positive direction, which means is a directly proportional relationship. Increase in one leads to increase in the other, decrease in one leads to decrease in the other. That's a proportional relationship, provided it's positive. Now, negative is an inverse proportion relationship. It's an inverse proportion, while an increase in one leads to decrease in other, inverse proportion. Then no correlation means there is no relationship at all. There is no relationship at all. These are key points about correlation. Then we move to what about key points, which are strengths. Having talked about the direction, the strength is we are able to establish that when we are determining the strength of correlation, we move from -1 to 1. And the negative one is not a value, it's just a direction aspect. When it's in the negative, that's a negative correlation. All right. Then +1 means a perfect positive relationship, -1 means a perfect negative relationship, and then 0 means no relationship at all. We are able to establish this in our previous section. And then we look at the key points as regards to the strength. We are able to establish various ranges to which we can use in our interpretation as regards to the strength of the correlation, where we have that 0 to 2.9 is a very weak one or none. If it's 0, it's none, but if it's 0 point something, it's a very weak relationship. 0.3 to 0.49 is weak. Then 0.5 to this and that, we have that in the previous section. This is the key, these are key points about correlation which we established in the previous session. We talked about the groups of correlation, where we have simple correlation and multiple correlation. Simple correlation, it has to do with two variables, checking relationship between two variables, whether there is relationship between the two. That's simple correlation. Then once it's more than two variables, then we are talking about multiple correlation. All right. And also we looked at types of correlation, we have the Pearson correlation, where we talked about it has to do with a normal distribution. The data set has to be normally distributed. We have to assume, we have to satisfy that assumption that is normally distributed and is a parametric sample. All right, it measures linear relationship. When we talk about linear, a linear is a highest power of your known to be 1. We established that Spearman is where we check based on ranks, is a correlation that is looked at based on ranks, which by God's grace we might be able to look at this night. Then is when the data is not normally distributed, we use Spearman rank correlation. If the data is not normally distributed and also is a non-parametric sample, then we use Spearman ranks correlation. And then we have the one we call the Tyndall style. Now, the Tyndall style is similar to Spearman in the sense that it makes use of ranks. However, it's mostly used for a small data set. And these are what we looked at and we consider the types of correlation. Just go over to the previous section. It was explained effectively in that section. All right, we also look at what is regression. We say regression is a statistical tool. In other words, now relationship, correlation checks relationship. It doesn't change the effect. It doesn't change the cause. The fact that the two variables are significantly related doesn't mean a change in one is caused by the other. It doesn't really mean that a change in one variable is caused by the other because they are related. No, relationship is not the cause of effect. Now, what we use to check causation or the cause is a regression to check the effect between a dependent variable and independent variable, where we call the dependent variable the outcome and independent variable the predictors. So in regression, it's a statistical method, it's a statistical tool, which we use to determine the effect or the relationship outcome between two or more variables. Now look at, we say it helps us to understand how strongly variables are related, how one variable changes when other change, which means is a cause, is a predictor, and then to make prediction about the future. We talked about this, and then we talked about the types of regression, simple, linear, multiple, logistics, and other advanced ones like polynomial, which we explained each and every one of them what it stands for. And then that is where we now wrap up why use regression, and this is where we wrap up to get to go into the practical section. Now, having run overview on what we have, let's quickly head over to Excel and then do what we have to do for today. This is a data set we will be working with. If you are with me on this section, please let me know what you are seeing right there on your screen. Let me know what is before you on your screen right now. What can you see? Drop in the chat. Type in the chat what you can see. Type in the chat. What can you see? Let me know. What can you see in the chat? What can you see in the chat? Drop it in the comment. Drop it in the chat. What can you see? Let me know what you can see in the chat. What can you see? Drop in the chat. What can you see? So that I will know that we are all on the same page. I'm waiting for us. Let me know what you can see in the chat so I know we are all on the same page. Okay, beautiful. Beautiful. All right. Beautiful. We on the same page. We on the same page. All right. Now we have this to be correlation, and we are looking at correlation analysis. Now remember, I said simple correlation is all about having to check relationship between two variables. Now when we are talking about relationship between two variables, if I want to check relationship between sales and price, the sales and price, then I can just take the two to check their relationship if they are significantly related. Or I want to check the relationship between price and advertising, whether a low price, whether they have a relationship. I can select the two depending on that. That's simple correlation. That's simple correlation. When we are talking about two variables, we are talking about simple correlation. All right. Now to do the correlation analysis, we head over to data, and then we come to our data analysis toolbar. I have shown us how to activate this data analysis toolbar. So we click on it. Once we click on it, this dialog box will appear. You will see this option here called correlation. You click on it and we say okay. This will show up input range. What range are we looking for? We are looking for these two range. Then I will hold Control, hold Shift, press the down arrow to highlight the entire range. And then it's grouped by columns. I have explained that if it's on the row side, if the headings is on the row side, you select the row. Then the next thing we know is that we highlight both the column headers. Hence, we label it. Labels in the first columns. Now, the next we look at is the output range. Where do we want it? Do we want it in a new worksheet? If it's new worksheet, we allow. If we want it in the same worksheet. If we want it on the same worksheet, we allow. Here, I'm going to select output range, and then let me click here. This is where I want the result to start from. That's where I want the result to start from, and then I click OK. Now, automatically we see what we have here. We see the result. What are we having here for the relationship? It's a negative correlation. The correlation coefficient here, based on this is a negative correlation. The relationship is very weak. Remember, this is 0.000. This is a very weak correlation and is negative. In other words, it's moving in the negative direction when we are talking about price, sales and price. Now, what this simply means is that when you are looking for a relationship between a variable to itself, it's a perfect relationship. It's a perfect correlation. It's a perfect correlation. When you are looking for a relationship between a variable against itself, it's a perfect correlation. One. That's why when you look at this price against itself price, it's a perfect correlation. One. Then when we are looking for price against sales, we now have a very weak correlation. Very weak. That if we remember I said that relationship is not causation. In other words, it doesn't determine the cause of any effect that exists within the two variables. It just states if the relationship is strong, if the relationship is weak, if the relationship is positive, if the relationship is negative. All right, that's for simple correlation. Now let's look at multiple correlation. We go to data analysis, we select correlation, and then say okay. Here we are going to select all this in the output range. In the output range, we are going to select everything here, Control Shift down. So this is what we refer to as multiple correlation. We are dealing with 1, 2, 3, 4, 5, 6. 6 variables. 6 variables to check the direction of the relationship and the strength of the correlation. The direction of the correlation, the direction of the relationship, and the strength of the relationship. That's what we are going to check as regards to each and every one of them. So once that is done, let me click here. The same column is there. The same this output range, I will select this. Let me click on this point for my output range. Now under output range, let me delete this and select here. Now let me select this here. So once that is done, I will say OK. Okay, let me use the front, and then okay, I think I see where my challenge is. Let me click that Control Shift forward, down arrow, and then I will say OK. Now we have our result. We have our result. Now look at this. It gives us a kind of matrix result. It gives us a kind of matrix, diagonal matrix, or not really diagonal matrix, a kind of matrix. Now when you look at this, remember I said the relationship or the strength or the correlation coefficient between a variable and itself is a perfect correlation. That's why you are seeing this 1, 1, 1, 1, 1, 1. This price against itself, advertising against itself. So that's why you are seeing stuff like that in this place. Now when we look at this is a negative correlation, negative, this is a positive correlation, and still weak. This is still weak. This is still weak. All the relationship, this one is average. I think, is it? No, it's still weak. This is very weak. This is very weak. This is very weak. When this is very weak. This is weak. This is very weak. Here there is no strong relationship. There is no strong relationship between them. Here there is, this is 0.4, this is 0.05, this is 0.1, 0.11. So here we have the relationship that exists between each of them is weak. Price against sales very weak, advertising against sales very weak, footfall against sales very weak, temperature against sales very weak, discount very weak, and so on and so forth. You can still check advertising against price, also very weak. Footfall against advertising, that's the one that is heading to kind of average. So that with this we can see the strength and the direction of the relationship. The strength and direction of the correlation. This becomes our correlation analysis. This is the correlation result. Now we have checked using the Pearson, this if, and I need to state this. What we did is Pearson correlation, because when we are talking about Spearman makes use of ranks. It ranks this according to order. Here I can come here and say go to home, and then come to sort and say sort from small to largest. It gives it ranks. I can come here and rank this one 1, rank this one 2, rank this one 2, rank this one 2, 3, 3, 4, 4, 4, 4, 5, 5, 5, and so on and so forth, based on this discount. When I rank it, if I now come here and put this one 1, because in the ranks I give it 1, which is the lowest, I can come and give this one 2, and then make it to be this, and give this one 3, and then make it to be this one 4, and then drag it down, and so on and so forth. So when I rank it from there to this, and then I use their ranks, if I rank this and then rank these ones as well, and then use their ranks in order to run analysis, that becomes Spearman. That's Spearman analysis, Spearman ranks correlation. However, in analysis such as this, we assume that this is a parametric sample, and at the same time is normally distributed. So we make use of the raw data. In Pearson correlation, we make use of the raw data. In Pearson correlation, please note that in Pearson correlation uses raw data, the raw data we have, raw data. Whereas when we talk about the Spearman or the Kendall, it uses ranks. So for us to use this raw data set, we are assuming we are making use of Pearson correlation. So what we have here are Pearson correlation coefficients, Pearson correlation coefficient results. So this is a weak negative correlation. Now, if there is a relationship that exists between the variables, we are saying that this is a weak negative relationship. Weak negative relationship. That is what we are talking about as regards to correlation analysis. Hope we understood this. We are moving to the next aspect. We are moving to the next as regards to the section tonight. I want to be a bit fast to cover some things for tonight's section. All right, we have talked about correlation. Let's move to regression analysis. Remember, we talked about regression models and that in the previous section. Let's look at it tonight. Now, in regression, we said that there are two types of types of regression. We have simple regression, simple linear regression, and multiple linear regression. These are two major regression types we are going to be dealing with tonight. Two major types of regression we are going to be dealing with tonight. The logistic model, maybe if time permits or next time, I might look at it for us. The logistic model. Remember, when we talk about logistic model, is where the independent variable has a case of 0 or 1, or yes or no. Yes or no, pass or fail. The dependent variable, well, let me finish the regression first. From there, we will understand what I'm trying to say. Okay, now in the simple regression, simple linear regression, as the data set implies, simple linear regression is where we are looking at one dependent against one independent variable, or one independent variable against one dependent variable. That's two variables, but one is independent, the other is dependent. Now, in data or in statistics, independent variables, we can refer to them as factors or predictors. And other names, they are factors or predictors. Let me bring it up a bit so that we can see it more easy, more clearly. So in statistics, in analysis, independent variables, we can call them factors or predictors. and then the dependent variables are the ones we can refer to as outcomes. So the outcome depends on certain factors. If an outcome depends on, or a variable depends on certain factors for each outcome, then that is a dependent variable. Now, in this case, sales depends on advertisement. We can say that advertisement, the amount spent on advertisement impacts sales. If we want to check if the amount we spend on advertisement has a positive impact or have any impact on our sales. Now, that impact, we will not determine whether the impact is positive or whether the impact is negative. So in that case, if we are checking if the amount we spend on ads, let's say social media ads, Facebook ads, Instagram ads, Google ads, you understand, YouTube ads, and all that, whether it has impact on our sales, then we can now clearly state that our independent variable, we can clearly state here that our independent variable here is advertising spend. That's our independent variable. Then our dependent variable. Our dependent variable here becomes, which is the outcome, the outcome is the sales. What we make after our advertisements, after we place ads, what does the ad perform well? What some of us, when we run ads, we begin to check if the ad performs well, and you begin to check some metrics, some factors, on some checks, some analytics you are seeing in your dashboards to know whether the ads perform well. From the ad, did it give you the estimated sale or the expected sales that you expect when running that ad? So the ad becomes independent variable, whereas sales becomes dependent. Now we need to first establish this. When you are running regression analysis as a statistician, as an analyst, as a data analyst, as a business analyst, as a financial analyst, as a project analyst, you as a health analyst, whoever in any niche, as a customer relationship analyst, in any niche, as a logistics analyst, it is your sole responsibility to determine, to understand the variables that are independent and the one that is independent. And in regression analysis is responsible for one dependent variable against one or more independents. I repeat, one dependent variable against one or more independent variable. Now, you might ask, what if I have two or more dependent variables? That's where in advanced data analysis, we have what we call MANOVA analysis. Remember, we have ANOVA. We have ANOVA, two-way ANOVA, one-way ANOVA. We have MANOVA, that's multivariate analysis of variance. We have MANOVA, that's advanced analysis. Especially those of us in research might have come across it. You have the MANOVA, you have the ANCOVA analysis of covariance, and then you have MACOVA, multivariate analysis of covariance. So that is a kind of more advanced analysis. All right. Now, but here, regression analysis, I need to establish that, and I need to emphasize on it. This on one dependent. Regression analysis is an analysis that deals on one dependent. Please note that against, I think the spelling is correct, yes, against one or more independent variables, against one or more independent variable or variables depending on. This is what regression analysis is all about. This is regression analysis. One dependent against one dependent against one or more independent variables. I know why I'm establishing this. So having understood what regression is a statistical tool that checks effects, relationship effects of one or more independent variables against the dependent variable. Now, having done that, this is a simple regression, simple linear regression analysis. Excuse me. So to do that, let's quickly head over to the data, and on data we click on data analysis, and then we move down. This is our regression. We click on it and we say okay. Now we are presented with this box. We are presented with this box, input y range. Remember, in the basic mathematics, x and y is just a dummy variable. However, x and y is already used worldwide. Let me say it that way. Already used worldwide. Now, y here is the dependent. Remember, let me close this. Remember when we wrote the regression model? We said this is next use of equation of a straight line for simple linear regression. For simple linear regression, it makes use of equation of a straight line y equals to mx plus ms plus c. Remember, we said that y equals to mx plus c. This is the regression model. Now, for this, if we want to rewrite it based on this, y is the dependent variable. Y is the dependent variable. Y is the dependent variable. X is the independent variable, and m here in mathematics we call it slope, but in this analysis we call it the coefficient. Yes, the coefficient. We call it the coefficient. That's the name. We call it the coefficient, whereas c here is the constant, or in geometry, which is the y-intercept, here we call it the constant. So this is what this thing stands for, and for us to transform it into the model we have, y equals to this plus this, what we will say under this is that ad spend, let me say ads, let me call it ads, equals m as the coefficient, or what can I use now to so that let me use a symbol. Let me use a symbol. Where can I get? Because the M, if I put M and then sales, it will look as if alphabet. Just let me use a dollar sign. Oh, dollar sign and S is T. Okay, let me use this hash and then sales. Hash stands as our M, then plus the constant. We call it constant. Now for this particular, this becomes our, this is now our simple linear regression model. What we have here is simple linear regression model. I know why I'm explaining this before running the analysis. Simple linear regression model. This is a model we can now use I don't need this equals to me. Let me put an apostrophe here. Okay. Now this model is what we can now use to make prediction. When we establish that there is a significant relationship between sales and ad spend, we can now make use of, we can now predict what our sales will be. Okay, I made a mistake, please. The Y is the dependent. This should be sales. Forgive me. Sales. Then here we have ads. That's what our model will be. Now, to determine what our sales will be based on an amount we decided, if we decide to spend the so amount on ads, what is our expected sales? Can we predict based on what we have previously, all things being equal? What are we expecting to get? All things being equal, what are we expecting to get? That is our model. This is what we call predictive model. Linear regression predictive model. This is the equation. So you can make it, you can use it for anything. If it's a health, you are predicting the rate at which a patient can recover based on the data you have. You can run it like this. This is the drug. This is the drug you administer, and this is the recovery rate, the recovery time. The recovery time is dependent on the drug administered. So the time administered to this drug, this is the drug rate, this is the and what we call it, the recovery time. I'm just giving that analogy. That means that drug becomes the independent variable, which is X. The recovery time, which depends on the drug, becomes our Y. You can now come here and change it. Recovery time, when you put any value here, which is the coefficient, against the drug plus the constant. So that becomes your simple linear regression model. This is this, and this is the simple linear regression model or equation. Now, having established that, having understood that, let's quickly go ahead and run this analysis. Data, analysis, and then select regression, come here. This comes out. Now we have established what our Y is. Our Y is sales. So we come here, select sales, hold Control, hold Shift, down arrow to highlight the entire range, Control, backspace to return where we started. That is for our input range Y. Then we go to X, which is our independent variable, which becomes our advertising spend. Hold Control, hold Shift, down arrow, Control, backspace to return. And then that's what we have. Having done that, because we selected both the column headers, and we have to click on this level. Now this confidence interval, we are assuming a confidence interval of 95%, which is the generally accepted. However, it's not a must. Like I have always been saying, it's not a must. It's not a must. If you are working on 99% confidence interval, you come here and you put it. If you are working on 90% confidence interval, just click here. When you click, you change it. But if not, there is no need. Then for the output range, I'm going to make it to be in the new, leave it on new worksheet, because here is already filled up. I don't want to cluster this place. Let me put it on a new worksheet. Now, what other things do we need? If you want a normal probability plot, you select. If you want the residuals, residual plot, standardized residuals, whatever you want, you select. But I always want to see my normal probability plot as regards to this data set. I select it, and then I say OK. It opens a new sheet. Now this a normal probability plot is this and this. Now we have our result. This is our result. Let me zoom out a bit so that, let me zoom in a bit so that we can see it. Now, in interpreting this result, remember we now have our regression statistics. This is our regression statistics. Obviously, mostly how will I put it now? Mostly the descriptive statistics, which talks about the R square, the adjusted R square, which they are very close, and then standard error, which is 46. And the number of observation 30. Now, please, I need to state this. For data analysis, I need to state this. When you run analysis, the larger your data set, the more accurate your result. I think I haven't said this before. In data analysis, the larger your data count or your data set, observation is 30. If we have like 300 instead of 30, the more accurate the result tends to be. The more accurate the result tends to be. So let's understand that. In running analysis, to get more accurate result, you need more data points. You need more data points. That is what I'm trying to establish. You need more data points. Now, in interpreting this a summary output, when you are looking at this, because it's a simple regression, we are interested in the R square, and the higher the value of R square, the more closer it is to 1, because whatever we are doing is between 0 and 1, or let's say -1 to 0, -1 to 1, which -1 is just about the negative. So the more closer the value R square is to 1, the more it tells us that, the more it shows accuracy. The more it tells us that our model tends to be accurate. The more accurate our model tends to be, the more close our R square is to 1, the more accurate our model is. Please note that. Now, why are we using R square here instead of adjusted R square? The reason is simple, because we are working on simple regression. In simple regression, so it's talking about only this and this. It's just only this and this, and that's why we are making use of the R square, not this one. That's why we are using this under the, that's why we are using this to check, this one to check under this analysis. That's why we are using this to check. Please note that under this analysis, R square, we use R square in our results. I know why. Interpretation is the key in analysis. Some persons can analyze, but to interpret the result is where the challenge is. And what makes you a data analyst, what makes you a full data analyst, is the ability to interpret your results and make informed decision out of it. So the arrow square, we use arrow square when it's simple linear regression. When it's simple linear regression. And then we make use of adjusted arrow square. Let me copy it and paste here. We make use of adjusted arrow square if it's multiple. Please note that multiple linear regression. That is when we use adjusted arrow square to determine whether we can trust our model, whether we can trust our regression model. Very, very important that we note that. So when we go for multiple linear regression analysis, we are going to be checking for this instead of this. Note that. Okay. Now, having established that, we come here for our ANOVA result. This is the one that is very, we need to pay more attention to, our level of significance. I have talked about what degree of freedom is, the sum of square, the mean square. If you miss the previous session, do well to go and check it and understand what we are talking about there. Okay. Now here we have results. Here we have results. Now remember, this is the intercept, this is the ad spend. Under the intercept, we have it to be 42.94, so. And then for ad spend, the coefficients of the ad spend is this. The coefficients. That's M here. This M, or this hash here, for ad spend, the coefficient is this value. So if I'm to look at this from here, I can now see that yes, there is significant. There is significant. Now there is significant effect that ad spend has on the sales. So we can agree that yes, there is significant effect, or there is significant effect between ad spend and the sales. So for us to write our regression model, I can now come here and say sales equals to this 3.099. Then type my ads plus the coefficient of the intercept, which is 42.942,999. Now this becomes my predictive model. What this means is that if I want to know how much my sales will be as regards to this particular model based on the ads, then I just have to determine, put in how much I want to invest in the ad, or how much I want to put in the ads. Let's say this I have here, let's say I have here ad spend, and then sales. Let's say I have these two. Under my ad spend, let's say I have 200. Here I have 220. Let me use these two and drag down. Now, this is what I have. Now, the thing here is that if I want to now, using this model, I want to determine how much my sales will be when my ad spend is 200. I'm using this model now. I can now say equals to 3.048899 times this, which is 200, times this, plus this. This is the coefficient. Now, if this coefficient is minus, this will turn to minus. Remember, the equation of a straight line is y equals to ms plus c. So if this is negative, this will be negative. This plus will turn to minus. If this is negative, here will be negative. Please take note of that. So plus 42 points, let me type it. If not, I can just click it here and get it, but let me type it out. 42.94299. Now that becomes our predictive model using this equation. So with that, I can predict what our sales will be, all things being equal, based on the normal condition, based on the same condition, the same everything, what our sales will be. So in that regard, I will now, having done that, this is my equation. This particular coefficient times this amount I want to spend, then plus the constant. This is constant 42 point this, and then I hit enter. It's showing me that my sales will be 652 point so this. That's what my sales will be. Then if I double click down, these are what I'm supposed to have. Based on this, the same thing is doing this, and that's what it shows that what we have here is a positive relationship. There is an effect, and this ad spend causes a growth in our sales. Ad spend causes a growth. The more we put in money in our ads, the more we are expected to have more sales. So the ad spend causes growth in our sales. So, and in that regard, there is a positive relationship that exists between ad spend and sales. As the ad spend increases, sales increases. One, it shows us the kind of relationship. It's a positive relationship. And at the same time, it shows us that increase in ad spend causes increase in sales. That shows concession using our predictive model. So with that, we have been able to draw insight, and then we can now decide to, okay, let's top up we can now decide and recommend from the data we have and from the model, if we can be able to invest so amount in our ad spend, our revenue or our sales will increase by so amount. That is what we have. All right, beautiful. I hope this is clear. I hope this is clear. Let's quickly move to the multiple regression. We have dealt with simple regression. We have dealt with simple regression. All right. If you have any question, feel free to drop it in the chat box. Feel free to drop it in the chat box. If you have any question, feel free to drop it in the chat box. I will be able to respond to that. All right. Are we following? Are we following? Let me know. Are we following? Are we following? Are we following? Drop in the chat if If you are following, let me know. Let me know that I'm not alone. And also, if you are with me here, kindly hit the like button on this section. We are gradually coming to the end of the scholarship cohort 1. Data analysis scholarship for cohort 1, we are gradually coming to the end. All right, beautiful family, now we are following. Yes, we are following. Be beautiful. Now, we are in the multiple regression analysis. Let me zoom in a bit so that it can be more clear. Now we are in the multiple regression analysis. Faith, good to get that feedback from you. All right. Now remember, in this multiple regression, we have talked about simple regression, where we looked at the sales against the advertising spend. Now we will be looking at factors, different factors that can affect or have impact on our sales. There is one thing about regression that I so much appreciate. When regression shows us that there is significant impact, there is significant effect, it also explains to us, it also shows us which variables has more impact than the other, and which one doesn't contribute to that significant impact, or whether all of them contributes to the significant impact. All right, it will be to get that. Allah should be good to get that feedback from you. That's one thing I love about regression analysis. When you are predicting or forecasting using the normal forecasting, you might not really get to know that, and then you are limited to 2 variable data sets. Okay. Now, this for regression analysis, I have taken time to explain all this. But for multiple regression analysis, the only thing I'm going to take time to explain here is that when we talk about multiple regression analysis, the regression predictive model, the multiple linear regression predictive model is in this format. Y is in this format. Y equals to, Y equals to M X MX, how will I put it now? How will I type it? Please, I will be explaining, understand what I'm typing. MX1 plus MX2 plus MS3 plus dots plus MXN plus C. This is the equation for multiple linear regression model. M is still the coefficients. M stands for coefficients. Here Y still stands for dependence. Dependent variable. X stands for independent. Can we hear me? Please confirm if we are back. I think network was a bit shaky. confirm. Can you hear? I think we are on now. Can we drop in the chat? Yes, the same. Can we drop in the chat, please? I think we are good now. Let me know. I believe we are good now. Beautiful, beautiful. So I was explaining what all this means. So if we are to replicate what we have here based on our data sets, here we are going to say that sales equals to, I can use my M will be, let me maintain the hash sign, and then ads plus the hash and the price plus my hash sign discount. Let me use this in a short form due to time, plus my hash and let me call it FT plus my hash, and then let me, okay, I can type it full season, then plus constant. That's what this explains. This is what we are seeing here is our multiple regression model to use to predict what our sales will be based on these factors. These factors we have here: 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. These are 5 factors that impact our sales. 5 predictors that can tell us what our sales will be if we impute all these things, all things being equal. Now, to analyze this, remember in analysis, we don't run analysis on strings. Remember that. We don't run analysis on strings. Follow me closely, please. Remember, we don't run analysis on strings. Hence, for us to make use of seasons here, we are going to code it. We are going to code seasons into numbers. We are going to represent them with numbers, because if I run this analysis, it will definitely not work. Now see what I mean. If I go to data and then come to analysis, come to regression, under regression I say, okay, now my sales is this. Let me remove this, come over to this, hold Control Shift, press the down arrow, Control backspace to return. That is what I have. And then I come to X, which are based on X. These are the independent variables. I will now come over to this, hold Control, hold Shift, forward arrow, down arrow to select all, because they are all part of the factors. These. They are all part of the factors. And then put label I want it in a new worksheet, I'm okay with that. Also, okay, the normal probability plot, if you want it, let's leave it. And then I say, okay. Now you look at what he's telling me here. He says regression input range contains non-numeric data. Non-numeric data. You don't run analysis on strengths. When I will talk about strengths are like characters. Strengths are non-numeric data. Let me put it that way. Like we have seen here. Non-numeric data can be hash, can be space, can be apostrophe, text, and what have you. So why this doesn't go is simply because of the seasons are non-numeric data. So in order to run this analysis successfully, we need to code these seasons. We need to code it. Now, to code these seasons, what do? We can come here. Okay, let's come between here and then know how many seasons we have. How many seasons we have in this data set. So to do that, we can say first to unique, come over to this, double click, click here, hold Control Shift, down arrow, and hit enter. Now it shows us we have 4 seasons. 4 seasons. Now let me copy this, Control C, and then let me get to home, paste it as values. Yes, I have it not as formula but as values. Now let's take for example, if summer, let's represent summer with 1, we call summer 1, let's say we call winter 2, autumn 3, and spring we call it 4. Now this we represent this. So this we represent it. Now we can come over to this place and say equals to this. Anywhere we see, let's not even say equals. Anywhere we see summer, we put 1. Anywhere we see winter, we put 2. Anywhere we see autumn, we put 3. Anywhere we see winter, we put 2. This is 2, 2, 2. Then spring, we put 4. And then let me drag it down. Then summer is 1. Let me drag it down as well. Autumn is 3. Like that. Here summer is 1. Then winter is 2. Let me move it down. So because I don't want this to move up, what I will do, let me freeze it so that, alright, I have freeze that. Then spring is 4, winter is 2. We assign a value. Remember, when you have repetitive data like this, strings like this, you code them with numbers. Summer is 1, winter is 2, autumn is 3, spring is 4. Or you can code this one is 10, 12, 20, whatever number you want to code it. But we encourage you to use smaller numeric values. Alright, now autumn we put 3, anywhere we see winter we put 2. And there is one below it, I have to drag it down. Then I put this one, 3, summer, I put 1. Now let me drag this down as well. Then autumn I put 3, spring I put 4, winter I put 2, autumn I put 3, winter 2, and then spring 4, winter 2, autumn 3, then winter 2, summer 1, spring 4. Then let's drag it down. Alright, then under autumn we have 3, spring 4, summer 1, autumn 3, summer 1. Alright, Now this is what we do. This is what we have to do to code this data set. So here we already know what 1 represents, we already know what 2 represents, what season, the summer 2, the what summer 3, autumn 3, spring 4. So that is what we need to do. Let me unfreeze this so that we can get fully into where we are. All right, that's how you code this. So having changed this data set, we can now go ahead to do this analysis. So we go to data and come to data analysis. Regression is there, select it. My Y range is the same. Now everything should work. Now this is my Y range is B6, which is this to this, down to this, then C6 down to G46. That should be it. And then my label is on new worksheet, and this I will say okay. Now my result will show. All right. Okay, let me zoom in a bit so that we can see what we have. Now we see the result. Here, remember the previously what we will be looking at is the adjusted arrow square, because this is a multiple regression. Remember that. So this is 0.79. Is still okay, is closer to 1, but not all that close. So hence we might not really say we are trusting this model fully, but it's still okay. It's close to 80%. It, as it is now, is 79.28%. We can say 79.28%, which is kind of okay. Now when you look at what we have here, from the significant, this shows that there is significant. The regression result in the ANOVA, the regression, there is significant. When you bring all these together, when you bring all of them together, it shows that there is significant. Now, in doing that, let's now look at this. We determine that yes, there is significant effect of the predictors, of the factors against the against our sales, against the sales. There is significant effect. However, what are the effects? Remember the last time I said, if the coefficient is negative, that means in our model it will be minus. So here, let me come over to this multiple regression. Let me copy this our model. Let me copy this. Ctrl C. And then let me come to this sheet. Where is the result sheet? Okay, this is the result sheet. Let me paste it below here. Or let me paste it. Okay. Now this is what our model is in order to predict what sales or our sales based on these factors. Now look at the p-value. This is our p-value. In general, when you want to look at this analysis, generally is saying these factors has a significant effect on our sales. These factors has a significant effect on our sales. However, when we're talking about the significant effect, the adjusted arrow square, how true, how well, how strong is this our model? That's 79.28%. 79.28%. So with that, we can decide whether to accept it or not. Then me, once it's below 80, I begin to, once it's below 0.8, I don't really give it a strong eye. But this is close to 8, I might consider this. But me, once it's below 0.8, it begins to go into the aspect of being pessimistic about the model. Okay, now, excuse me. Coming over to this, we now begin to look from here which of these are p-values, which of them does not really contribute to the impact of our sales, which of them doesn't really have effect, which of them doesn't really have any effect. In other words, we can do without it, we can neglect it and focus on the ones that have effect and still get the desired result we have. That's where the regression shows us. Here you can see this ad spent, yes, it has effect because it is less than 0.05. This one, when you look at this, is showing us that the price does not have any impact, any effect on our sales. So we might not go to review our prices. We might not need to review our prices. Why? This is 0.4. In other words, it's saying there is no significant effect, that the price does not have any significant effect on our sales. Hence, we might not go to make decision in order to review our prices and see whether we can increase price or whether we need to reduce price in order to attract more sales. It's telling us that based on our pricing, that our pricing we have does not have any significant effect on our sales. So with that, we can consider it, like we can see here. This is 0.4, and 0.4 is greater than 0.05. And in our hypothesis, we say that once P is greater than 0.05, or once P is greater than significant standard, here our significant standard of significant is 0.005. Why? Because we selected 95% confidence interval. Another one that shows us is this, seasons. Is saying that our sales is not affected by seasons. That our sales is not affected by seasons. That season doesn't have any effect on our sales. That's 0.3. So we might not say, okay, maybe during this season that the season has effect on our sales. So let's not do a thorough analysis as regards to sales. Let's check the total amount we made per season. He's telling us, as you see here, it doesn't have any significant effect. Now, we can come down to this. This is our sales. We can look at this and say equals to sum if. Sum if. Let's say sum if. I'm going to use 1 because here 1 represents summer. Because I'm going to use this data set. 1 represents summer. Now we are going to say sum if the range is this. I'm going to select this, hold Control, row shift, down arrow, and press Control backspace. That's the range. And then press F4 to lock it, comma, open my quotation, and then what am I declaring? Sum if. No, it's not, it doesn't even need, it's a numeric value. So I put 1 here, and then put comma, and what's the sum range? The sum range is this. Hold Control, row shift, press the down arrow, then Control backspace. I need to lock it with F4, and then hit enter. It's showing me the sum is this. Now let me drag it down. Now you notice that there is no change. They are mostly the same. Now look at it. It sums up this. There is no significant difference. there's no significant effect. If I look at this, okay, forgive me, I did something, let me change it, forgive me. The criteria, in the criteria is this is the criteria, that's what I should do, and then hit enter. It gives me the same result, but now let me drag it down. Now here you see within this is in this range, there is no significant effect, only winter, other ones are within that range. So here is showing us that the effect, there is no significant effect. Where is okay, not even is here, okay, I think it's here. Now this is showing us the p-value. Season does not have effect. Why? Because when we look at it here, most of them, this and this are within range. It's only this which we can call the outliers. They are in a deeper analysis, that's what we call the outliers. This is just a fluke. Is considered as a fluke, something that is just happened, a fluke, just like that, is outliers. So when this and this, they are all within the same range, then we can now say yes, there is no significant effect. Season has on our sales, because most sales we have in seasons are within that range. So we cannot say that season have effect on our sales. Now from what we have here. Okay. Now, but this one you see E, this one you see 0.002. This is less than 5. This is less than 0.05. This is less than 0.05. This is less than 0.05. Hence, we can now determine, we can now know that this and this are the stores that have effects or that contributes to the effect. If we give discount, it impact our sales, and ad spend impact our sales. These three impacts on our sales, and that is the aspect in our regression analysis. And in the previous video, I have shown us how you can write your interpretation. This test was done using regression, multiple linear regression statistics, or multiple linear regression. For example, to interpret your results, if you want to interpret, you start by saying this analysis or test, this analysis was done using regression, using multiple linear regression. That's the first. Then you talk about your regression statistics. You include your regression statistics, your adjusted, let me copy this due to time, Ctrl C, you paste here, and then copy this, paste here. Now this becomes your regression statistics. Then your results, you can now say there is significant effects of there is significant effect of ads. I'm going to write it in short form. Ads, comma. Now from the result, you have noticed the ones that has effect, that contributes to that. You can now say there is significant effect of ads. This is the once I discover the wrong discounts, or let me call it FT. There is significant effect of ad discount FT on our sales. This, then you talk about your p-value, general p-value, then you talk about the individual p-values, and then you can talk about also the p-value of price and seasons, and then say that there is no significant effect of price and seasons on our sales. From there, you can make certain informed decisions. And this is how you look at your regression analysis. Multiple regression, simple regression, your simple correlation, and the multiple correlation. Hope we are following. Hope we are following. I'm taking my time to break this down because interpretation is the backbone as a data analyst. If you can't interpret, then you are just an intermediate person in analysis. What shows you a good data analysis? Ability to interpret your results. I'm saying that now. Ability to interpret your result is what shows you a good data analyst. All right. Now this is how you interpret your results using your p-values, and then make some decision to the extent where you can trust your model. This is your multiple regression model, to the extent to which you can trust this model. That's what we are talking about. To an extent to which you can trust this model. Now you have your probability output, your percentiles, and your sales, which we have here. Now, having established that, before we wrap up this section this night, I'm going to teach us certain things. There is something, someone reminded me of that. Someone reminded me of that on my DM. What I said in one of the sections about showing us how to import data from the web, and then or connect our data to the web, or import data from the web and state that data connection. What that simply means is, as the data, if the data in the site or the website is updated, automatically our data set will update. This makes sense if our company uploads data on the website, and we take data from the website to run some analysis for the organization and make informed decisions. So if you get your data set of the company from the company website, and every now and then company uploads data, company updates the data on that site, automatically your data set you have on your PC, on your Excel, will automatically update once you refresh that data set. So that's why understanding how to import data from the web is important, and state that connection is important as well. The reason is simple, because if you work for companies that upload data on the internet, on their website, and you get data from the website, not directly from the source, the person's the data you use to analyze, to make certain decisions, either from your branch or so, is you got it directly from the company website. Hence, to they need to link that data set to your PC, that data table on the website to your PC, so as once that table is updated in the website, automatically once you refresh it on your PC, it will update. Okay, now to do that or to get data from the website, we also go straight to data, click on data. Under this get and transform, we will see this aspect from where. So you click on it, it will bring up this dialog box. Now once you look at this basic advanced, we keep it here, you need to paste the URL. In other words, the link to that particular web page that has that table you want to import into Excel. I repeat, the URL and the exact URL of that web page that has the data set or the table to which you want to import into Excel. Now to do that, let's open a website or Wikipedia or so and get some link and then see how that is done. Okay, now let me search here. Okay, I think I have done some search. I like football. Let me use that World Cup trophy standing. Let me use this World Cup trophy standing. Okay, let me click on this. This is a web page. Now, how do you know whether this web page has table? Now, you are not importing this test. Remember, you don't run analysis on test. You look at for tables, whether this particular web page has table in it or data sets in it. When we scroll down, it doesn't really have. This one doesn't really have. So let me go back. Let me check this one and see if it has a table in it. These are write-offs. I'm not interested in them, so that you know the kind of data we want to get. All right, I've seen one like this. This is a table. Like this is a table. It shows me confederation, time hosted, host, upcoming host. This is a table, is in tabular form. As you can see, also this one is in tabular form. This is in tabular form. This is in tabular form. All right, as we move down, we also see stuff like this, teams, also stuff like this. There are other Please, can you hear me now? Can you hear me now? Can you hear me now? If you can hear me, let me know, and let me know where you stop hearing me, so that I can repeat. Can you hear me now, please? Can you hear me now? Can someone confirm in the chat whether you can hear me now? All right. I need another confirmation from us, please. Okay, beautiful. Now, please let me know, just tell me in the chat where you stop hearing me. From where exactly you stop hearing me, so that I will explain again. We have few minutes to wrap up tonight's section. Just let me know where you stop hearing me, so that I will explain that again. Thank you, Shutu. Thank you, Tembe. Thank you, Akimola. Thank you, Balogun. I've gotten your feedback. Let me know. Can you let me know where you stop hearing me? which part, where? Since you wanted to enter the data, which data, please? Is it when I started to, is it during the time of importing from websites, or is it still during the regression process? Is it the multiple regression section, or when we are talking about importing data from the website? At what point? Is it still during the regression section, or at the point where we are talking about, I'm talking about importing data from the website? Please, let's explain. Let me know where I can, let me know so that I know how and where to help us out here. I didn't even know that my mic is no longer audible. Okay, from the web. Thank you. All right, we are going to run it again. Let me open another sheet. Let me open another sheet. Now I said for you to import data from okay, for you to import data from websites, whether it's your company website or you are getting data from a data source, from the web, any aspect, you just get to come to data. Under data, you say from the web. Once you click from web, a dialog box will appear. Now this dialog box will appear. You will need to paste the URL of that web page, not the website, the URL of the web page. That's what we mean by web page. When we get to this place, this is a web page. What you are seeing here, this is a web page. The website is wikipedia.org. This is a web page. So in this web page, we have different tables we are talking about these tables, this and that. So if I want to import these tables for my analysis, maybe I want to use it for sports analysis and all that, I will come over to this place, highlight this, press Ctrl+C to copy it, head over back to my Excel, and then come over to this place and paste it. Paste the URL inside this place and then say OK. So once I say OK, start establishing connection and all that in the background, and then start searching. That web page that I entered, does it have any table on it? Is there any table it has that we can import into Excel? Because Excel works with tables. Excel is columns and rows. So after the analysis, it finds out that it has 49 tables. But in these tables, not all of them are relevant for us. We have this. It shows us the preview. We click on this. It shows us the preview. This one is the one we just imported. You can move forward to see every other stuff that it has. Now we have done this previously. Let me use this one to import this one into this place. Now this one, you look at it, you see that it will need some cleaning. Here we have no. It will need some cleaning. And why is none here? Now let me explain why it's being written none. Because in the, let me go over to this table here, the one we brought in. Now you see this, it merged. here, when you look at it, under this table now, these two are merged together because they are on the same goals, 13, 13. And these two are merged together because they are on the same goals, 12, 12. The same way, and all these merged together. They are on the same 13, 13. So that is why when we get to Excel, on this, you see no, no, no. So what we need to do is we can now take it to transform, to Power Query, to see how we can rectify that particular issue. So here is showing us that there is a challenge. Here is 1 to 10. We can delete it. So if we click here, I click replace value. Now I can say replace it with 4 because they are the same score line, and we have here it replaces with 4. But the thing there is it does that for all where it sees no, and it puts 4. So there in this I can remove that. Let me remove that step. It comes back to null. So what I can do here is let me replace null with same. Same is telling me that it cannot go. Okay. Because the data type there is numeric, so I will say replace it with 0. Let's anywhere we see that, replace it with 0. Okay. Now I think we have settled that. Every other thing is okay. Every other stuff is okay. And then we say close and load. We can change the name of the table. We can come here and call it World Cup top goal scorers. That's the name, and then we say close and load. So we wait for it to import, establish all the loading, the connections and all that, and then bring in the data into Excel. Now what that simply means is that once on Wikipedia, once that is updated, let's say in the next World Cup, Mbappe has scored, maybe Mbappe scored 5 goals to become the leading all-time goal scorer and all that, and then the table is updated and changed. When we come over to this place and click on refresh all, it will refresh. It will update. That's the beauty of it. It will update. But currently, that is the stand. Here now we can come over to this place and put 4, and come over to this place and put 6, come over to this place and put 8, and then come over to this place and draw down for them to be 10. That's what we can do on this. So that is how you get data from web, and to establish a connection, that's the main important aspect of this, to establish a connection with the data set you have in Excel to that web page. So as once there is an update, once the data in that web page updates and you refresh it here, it will automatically update. That's what we are talking about, getting data from the website. All right, now another one to wrap up this night is getting data from PDF. If you have a table, if you have a data in a table in PDF, you can convert it straight in Excel and run your work. No need of copying it from the PDF to come and paste in Excel. And to do that, you will come to data. Under this, you come to get data. Now under get data, you come from file and come to PDF. Now under PDF, I'm not sure I have any PDF stuff that I can import data from. I can import table from, I'm not sure. So if you have, yes, if you have any PDF, you select, and that's it. If you have that PDF, the table, that PDF data set, that PDF file that the table is in it, you select it. Okay, let me just quickly do one or two here. Let me say Control C. Let me open my Microsoft Word. Let's quickly do this and we wrap up for tonight. I think I have taught us this first session, how you can link your stuff. We have taught us that. Yes, so this is what we have. So now let's say I'm saving it. I want to save it, but as PDF. So I can go to File, come to Save As. Let's say I want to save it on my desktop. I select desktop, and then let me call it regression, and then let me save it in PDF, and I say save. It is saved in PDF, and that's the PDF form. That's the PDF form of this file. Okay, let me close it. We have gotten one. Let me close it. Now, okay, we can use this. Let's go ahead. Let's go over again. Get data from file, from PDF. Now, in that, I'm going to select desktop. Under the desktop, I have regression. I select regression and then click on import. It starts establishing a connection. So on that, it brings up the regression. I click on this, it shows me this. If you click on this, it shows you this. So either way, then I select this, and then if you want to transform, if you want to do any further cleaning, which I don't need to, you click on transform. But if not, you click on load. So once you click on load, automatically from PDF you load your data directly in Excel instead of copying it and then coming to paste. You load it as a table, establishing a connection from that PDF file. All right, that is how you can get your data from PDF from the web. Okay. So you are asking, what if the PDF is in Word and not in table or not numeric and wanted to insert in Excel? You need to understand that Excel is a spreadsheet. Excel is a spreadsheet, and what it means is that Excel works with tables. Excel is a spreadsheet, and what makes anything a spreadsheet is that it has columns and rows. So whatever you are talking about, if the text is in tabular form, Excel will dictate tables. You can see when we did the web page, it didn't dictate any write-up. It dictates those ones that are in a table. It dictates 49 tables that are available in that web page. So once it's in Microsoft Word and it's not in a table, it will not. Excel works with table. That's just the fact. Excel works with table. Is when we mean table, we mean columns and rows. Like you can see A, B, C, D, and this 1, 2, 3, 4. That's what Excel works with. So if you have any table, any data set that is in PDF, that's the essence of importing. It's not just importing anything, a data set that is in PDF, a response that is saved in PDF format, and you want to use it in your Excel sheet, you can import it directly from that PDF instead of just copying and paste. It makes it is manual, and at the same time is not the right way. Okay, I think I've answered your question. If there is any other question, you can do it to drop it. Right now, we have come to the end of tonight's section. My attendance is on. Your name and your scholarship ID, we haven't really forgotten that. Those that have been with me from start to finish, I know them. Those that have been with me from start to finish, I know them. So at this moment, your name, your scholarship ID, and let me know how is the section tonight. We have come to the end of tonight's section. Let me know how is tonight's section, and also your name, your scholarship ID. Your name, your scholarship ID, much appreciated. And how is tonight's section? How is the section tonight? How is the section tonight? We have come to the end of tonight's section. Let me know how is the section tonight, and your name, your scholarship ID. Let's do that. I'm taking note of those that have been with me from start to finish. Good to have you online, Toshitu. Wow, 001. You have been represented. You have been really 001. All right, Amina, you have always been around. Yoma Clara Wankwo, yes, you have always been around. Joseph Kende, good to have you. You have always been around. I know those that have been around. How is tonight's session? Let me get that feedback from you. Let me get that review from you. How is tonight's session? Let me know. I learned a lot today. Again, thank you, Timothy. You have always been around as well. Your name and your scholarship ID, don't forget to do that, Timothy. Remember to do that. All right, that feedback is very, very important for me. That feedback is very, very important for me. Thank you so much. And see us again on Saturday. Remember, we ought to have ended this week, but due to some logistics and technical challenges, we couldn't finish. See you again on Saturday. Saturday we will be learning data modeling. We will be looking at data modeling, and as time permits us on Saturday, we start data visualization and reporting, building dashboard, how to build dashboard from the scratch if time permits us. That is what we do. Joshua Faith, good to have you. You have always been around, I know that. So from on Saturday, we will be having another section on Saturday. On Saturday, another section, powerful section on Saturday, which we will be looking at data modeling. Data modeling, how to model data in Excel, and then take it up to data visualization and reporting, how to design a dynamic dashboard, how to analyze large data sets, use it to make an informed decision, design a dynamic dashboard that will cut the eyes of every employer or any employer, and that makes sure that shows that yes, you really know your onion. So make sure you are with me on Saturday, and then we will wrap it up on Monday next week. By the special grace of God, we will wrap it up on Monday next week, and then we now get our capstone project. That by next week Monday we will receive our capstone project. This is the overall project that we will do as far as this scholarship is concerned. The other ones are weekly project assignments. Now it will be where we get our capstone project, and that is where I will wrap up tonight's session. Good to have us. Thank you for being with me. Thank you for not making me to be alone, allowing me to be alone on this journey. I really appreciate us. See you guys on Saturday. Good night.